Imagine this. You've just signed $1 million contract for an AI solution that promises to revolutionize your business. 6 months later, the project is behind schedule. The AI isn't performing as expected, and the vendor is telling you it's out of scope. Sound familiar? This is the AI contract trap. Fixed-price contracts, designed to create certainty, often backfire in AI projects. And today I'm going to show you why that happens and how we can fix it. Because if we don't get this right, we risk AI projects turning into black holes, consuming time, money, and trust. The false promise of fixed-price AI contracts. In traditional software, a fixed-price contract makes sense. You define requirements, build the system, test it, and deploy it. It produces a predictable outcome. But AI is not a product, it's a learning system. It evolves based on data. It improves through iteration. And it fails in ways we can't always predict. And yet, we still try to fit AI into rigid contracts that assume perfect predictability. Let me ask you something. If a model underperforms because the data was noisy, whose responsibility is that? If an AI solution needs constant fine-tuning, is that part of the original contract or an expensive new deal? If an AI chatbot hallucinates information, do we call that a bug or the nature of AI? See the problem? Fixed-price contracts assume certainty in a field that thrives on uncertainty. And this is why 70% of AI projects fail before they generate real business value. Rule number 1, if you don't exclude it, you'll end up paying for it. A common enterprise issue is that stakeholders expect AI to work like magic. In reality, AI can only do what it's trained on. While fixed-price contracts focus heavily on scope, they rarely define what is out of scope, which can lead to scope creep, misalignment, and conflict. Does your AI need to aggregate data from the internet? If yes, have you estimated the cost and risk of web scraping and API usage? Is multilingual support required? Many AI contracts assume English-only models, only to realize mid-project that additional language models are needed, at a huge cost. Are you accounting for both false positives and false negatives? Most AI fraud detection projects focus only on false positives, minimizing business loss, but ignore false negatives, which can let real fraud slip through. If you're not including these in your AI model, explicitly list them in your exclusions. Otherwise, you'll spend months dealing with bad blood, scope creep, and project failure. Rule number 2, AI is an experiment. Price for discovery, not delivery. One of the biggest myths in AI estimation is that AI projects take less time than traditional projects. They usually take longer. Why? AI is experimental. It doesn't follow a straight path. AI is probabilistic, meaning results are never 100% predictable. AI is data-driven. If your data is bad, your AI will be bad too. It's a classic case of garbage in, garbage out. Exactly what happened with Amazon's AI recruitment tool.
Ryan, this new recruiting engine was supposed to identify candidates that Amazon might hire, but it appears this program chose far more men.
Yeah, it's kind of garbage in, garbage out, unfortunately.
Here are some key pricing considerations. Always bake in enough contingency in the budget because AI troubleshooting takes time. LLM readiness. Your pricing will vary drastically based on whether you're fine-tuning an existing model or training from scratch. Hidden costs. Model retraining, prompt optimization, and infrastructure costs can change dramatically based on model usage. So, before finalizing the price, evaluate how ready the underlying LLM, large language model, is, the expected fine-tuning cycles required, the impact of data drift and ongoing maintenance. Rule number 3, miss dependencies, and your AI project will crash before it starts. Many enterprises throw complex, unstructured data at AI, expecting instant results. But AI is not magic, it's math.
Because so much of AI is misunderstood. People believe that AI is some magic formula that you type in a few lines of code and the machines just figure things out. That is not the case. Our AI is a really much more boring but honest version of AI, and that just means doing a lot of little things, creating a lot of very specific small instructions that we've built up over 20 years so that a machine can follow those instructions and replicate the things that a very smart human can do. It's kind of a nerdy way to put it, but the takeaway is we had to go through hundreds of thousands of financial filings and explain exactly to the machine how we wanted that data to be organized. And once you've done it enough times, then the machine can begin to take over parts of that process.
Stakeholders expect AI to automatically understand abbreviations, slang, or code names. But AI won't do this unless it has been trained specifically for it. You may encounter similar issues, so what's the solution? Include a data pre-processing phase in your SOW. Factor in the time needed to clean, structure, and validate enterprise data before feeding it into the model. Another critical aspect, understanding token needs. AI models consume tokens, and in an enterprise setup, this can become complicated quickly. Common challenges with AI tokens. Check lower environments may not have enough allocation for large-scale data processing. Enterprises may require a token usage tracker API. Did you budget for that? AI architecture teams may want to switch between different LLMs to optimize costs. How does that impact your budget and timeline? So, before signing the SOW, ensure all non-functional requirements are carefully considered and accounted for. Rule number 4. If your completion criteria isn't built on accuracy, your AI is built on hope. When it comes to fixed-price contracts, defining the completion criteria is the single most important factor. In traditional software projects, completion criteria are straightforward. If the software meets the functional requirements, the job is done. But AI is different. AI models do not function like traditional software. They are probabilistic, not deterministic, which means they do not always produce the same answer for the same input. Because of this, the completion criteria for AI must be defined differently. Instead of just focusing on whether the AI is working, the contract should specify how well it is working, using clearly measurable accuracy metrics. Let's explore why this is so important and what metrics should be included in your AI statement of work. Why 90% accuracy is not a good completion criteria. A poorly written SOW may define completion criteria as the fraud detection AI must achieve 90% accuracy. Sounds reasonable, right? But this oversimplified definition can lead to major business problems. Let's break it down with an example. Imagine a fraud detection AI is analyzing 1 million financial transactions. Out of these, 99%, 990,000 transactions, are legitimate, not fraud. Only 1%, 10,000 transactions, are actual fraud. Now let's say the AI system correctly identifies all the non-fraudulent transactions and gets them right. That means it correctly classifies 990,000 out of 1 million transactions. AI system's overall accuracy equals 99%. This sounds like amazing accuracy, right? But this AI system is actually useless. Why? Because it completely missed the 10,000 fraudulent transactions. The AI may have been 99% accurate overall, but it failed where it mattered most. This is why accuracy alone cannot be the completion criteria for AI projects. AI systems must be evaluated based on the specific types of mistakes they make. The two most important AI performance metrics: recall and precision. Recall, meaning how many fraud cases were caught. Precision, meaning how many flagged cases were actually fraud. Let's understand the recall. Why missing fraud is dangerous. If the AI finds all the fraudulent transactions, recall is 100%. If it misses some fraud cases, recall drops. A low recall means fraud is slipping through undetected, which can lead to huge financial losses. Precision measures how many fraud alerts were actually correct. If the AI flags 10,000 transactions as fraud, but only 7,000 are truly fraudulent, precision is 70%. Imagine a fraud detection AI incorrectly blocks thousands of legitimate customers' transactions. The result? Angry customers, increased support costs, and even regulatory fines. When writing an AI contract, avoid vague goals like, the AI must be 90% accurate. Instead, set clear and specific targets. The AI must correctly identify at least 90% of relevant cases, recall, while keeping errors low, 90% precision on a defined test set. This ensures realistic expectations and measurable performance that align with business needs. The bottom line: fix the contract, save the AI project. The difference between a successful AI project and a failed one? It's not just the technology, it's the contract that governs it. AI is transforming the world, but only if we structure our agreements to reflect the reality of how AI actually works. Because the future of AI isn't just about better models, it's about smarter business deals. Stay tuned for more in-depth discussions on each of these topics.